Greetings, Earthlings. Well, it's round 2 here on replacing the fuses on this HP 3476A. That's the original blown fuse. Okay, so if you recall from the last episode, it wants a 32 milliamp fuse here, which you just can't find. And that's like an AGC, which is 1/4 inch, 250 by 1 1/4 inches. No, 1 1/4, that's right. 1 1/4 inches long. So what I've done is these are readily available. These are 32 milliamp fuses, but they're 5 by 20 millimeters. Okay? You see that? Or, let's see, diameter 203 thousandths, 0.203, and the length is 0.788 inches, or 5 by 20 millimeters. Okay. This is 1/4 inch brass round rod. Okay. And so that is 1/4 inch diameter. Yeah, right there. Really, trust me, it's a 1/4 inch diameter. And so that would fit in there, you see. So my idea is, now I believe this is, it's spring loaded in there. But what I see is on the side here, the contact that's out is on the side. The innermost one would be on the end. There's a spring there. So my idea is to make a piece out of brass that will extend this and increase it to 1/4 inch on this end, you see, and make it 1 1/4 inches long. This end will still be the 5 millimeters, so that shouldn't matter. And then that should let me, that should allow this fuse to be used in that meter. So, to do that, we need a lathe. And here we are with the brass, I don't know if you can see that, chucked in the lathe. Yeah, there it is. See that? Okay. And first thing we're going to do is drill a hole. Now, again, this fuse, this mini fuse, is allegedly 5 millimeters. But it measures with these calibers 0.204. 5 millimeters is equivalent to 0.1969 or 0.197. So this is a little oversized. Here's a number 6 drill, and that measures with this about the same diameter as this, which would make it a press fit. But I think because of the slop, the hole's actually going to be bigger. We'll center drill to get the hole started so that in theory the drill will go in straight. Okay. Let's now move to a number 6 drill. Check the fit, the fuse. Oh, that's nice. That's a nice sort of tight friction fit. That's the way, that's what I want. Okay, and the length, I call that good. Okay. So, I'm going to take this out. Now I want to make this 1 1/4 inches. So this, whoops. I'm going to mark that. You know, we don't have to be terribly precise here. Again, there's a spring on the end, so you know, if we're within a few thousandths, we're fine. Yeah, okay. There, I've got a bit of a mark there. What I'm now going to do, proper way to do this would be to use a cutoff tool, and I have one, but I don't know where it is. So I'm going to just take this over to the bandsaw, cut it off, and then we'll come back and face it off to length. Okay, can you see that? Cute. There it is. It's a little oversized. I don't know if you can see the mark on camera there. All right. So, whatever length that is, we're going to call it good because it was so close to begin with. I'm going to just round off those edges a little bit. Yeah, that's pretty good. Okay. So there's the finished piece. See the end. And here is it with the fuse installed. Okay. And that, at least at one end, and lengthwise, you see matches the original fuse. All right, so here we are back in the Mad Scientist lab. What was that last place? Well, that was the Mad Scientist machine shop. I don't know. And I've got my fuses here that I'm going to use. There's our little 32 milliamp fuse with the adapter that we made. And for now, I'm just going to use this 1 amp slow blow because I haven't got any 1.5 amp fuses, and I don't really do current measurements, so that's just going to be fine as a placeholder. All right, so we'll plug this in. We're going to put these in and see if indeed this works as intended. Okay. Now the trick to this is banana plugs. Banana plugs you use to push that in, you see. Push that in. Okay, and you gotta, this is one of those three-hand operations, really. Because I need to be pressing on both and slide at the same time. Uh-huh. Don't try this at home, kiddies. Go. All right, HP, you lose points for this design. Totally. Taking it out of camera range because I can't. All right. There, you see I've got it started, so now I'll slide it shut. I said I'll slide it shut. There we go. Okay, man. And I'll plug, again, I don't have proper test leads. Well, I don't have probe test leads. I have these clips, which is what we'll use for now. I'm going to plug this in. It hasn't warmed up. But we'll see if it turns on. Let's see, I'm on volts right now. So that should be measuring 0, and if I give it all the help it can, okay, it can have, there you go, that's 0. That's good. That's probably in spec, huh? AC volts. Yeah, still pretty good. Current should be 0. Okay. Good. Resistance should be 0. Oh, that's good. And that's open, infinite. Okay. So now, as a quick check, I have some precision resistors here in this box. And these connectors are made to, you know, stick a probe in there like that, and I'll hold a probe. But again, I don't have the probes for this, so I'm just going to have to hold them here. Okay. So this is a 1K 0.01%. 1.01. That's probably within spec, but not close enough for me. 10K, 0.005%. 10.02. Well, that's not good enough for me. Should be oh no, it's 0.005. I mean, come on, that's within half an ohm. This is 100K, 100.1, okay, and 1 meg, 1001. Okay, so it is within a couple of counts, which means it's within spec. So if I sent it into the Cal lab, they would just send it back and say it's good. But I want to I want it to be oh my. Okay. I want it to be spot on, because it's like, this is only 3 digits, you know? So we're going to see if we can get it there. This is odd. This beast is on standby, and it's putting out negative -1/4 volt according to that. If I turn it on, see, the dials are all set to 0. If I turn it on, it should be pretty close to 0, and it is. Okay. So, 1 volt. That's good. 10 volts. Let's see. There's 10 volts. Oh, no, that's 1 volt. That's 10 volts. 10.00. Okay. 100 volts. And we aren't going to go any higher than 100. Dang, that's spot on. 5 volts. Oh, wait. Well, okay. Can't get much closer than that. So, it's within spec. It works, first of all, with that fuse. Actually, I'm curious. This may blow it up. I'm going to put 5 volts. Well, let's see. I have current limiting on in this, but okay, so this will be interesting. I am going to look at how much current it draws. I'm going to switch it over here. Okay. So just trying to measure 5 volts on the resistance range will not blow that fuse. That's good news. So who blew it? How did they blow it? I don't know. We're going to calibrate this thing. We're going to open it up, check it out, calibrate it. Power off. Just because, like I said, I expect it to be spot on since it's only 3 digits. Well, and we'll see if that's really practical, or if I end up messing it up. But I have the adjustment procedure here from the manual. So, all right, no calibration stickers. Oh, I see. That's interesting. Now, okay, now we can get a good look at the fuse thing. So, like I said before, the outer one here is on the side, and the inner one is like a spring that you push against. Okay. All right, let's see what we got here. There's another fuse. Here's a nice capacitor. Adjustments, I believe, are under here. Shield must be in place for AC volt calibration. Okay, so there's 2 things that are accessible with that shield in place. Let's look. Got to be careful here, by the way. This got static sensitive parts in it. One in particular that is a hybrid that does all the work. So we do not want to be blowing that up. Okay. That is removed. Okay, and there you can see there's the hybrid right there. I won't even touch it, I'll just point at it. Here are my adjustments. Variable capacitor there, but resistance. Nice looking piece of equipment there. Ohms adjustment. Now they're saying connect a jumper wire across the fuse that protects the fuse. Set the multimeter function to k ohms and connect a 1 megohm resistor. Ha! I am not going to follow these directions. Because here's the thing. That fuse is in series with the resistance that you're measuring. They have you, in these instructions, adjust to the wrong value. They're assuming a certain fuse resistance, is what I would say. And I'm not going to make that assumption. I'm going to, because the fuses that I'm using may have different resistance than the proper ones that they're replacing. So I'm going to use these resistances, these resistors, but I ain't going to use the jumper. Okay? K ohms. And 1 megohm we're doing first. And that's reading spot on 1000, which is where it needs to be, where it should be. Okay. And then change to 10 K ohm. And it's reading 10.01, so I want to get that one spot on. So that's R16. R16. That's now spot on. I'll go back and check this one. And that's spot on. Okay. So I think I'm happy with that. Now, yeah. Now let me check. I have 100K here, 0.01%. $99.9. Oh, come on. Here's a 1K. 1.000. Okay. All right then, and with calibration complete, let's just run it through its paces. Verify that everything looks okay. Start with resistance. So that's infinite. And that's 0. Excellent. 1K. I said 1K, 1,000. Good. 10K. 10,000. 100K. 99.9. 1 meg. 1,000. That's all good. Okay. DC volts. Oops. Yeah. 1 volt. 10 volts. I can go to 100. Yes, I can go to 100. 100 volts. Okay. Fuses are rated for 250, so I won't go over 100. Well, I could go to like 150. 150 volts. Spot on. What about lower voltages? There's back at 1. Let's go 0.1. Oh, 0.2, that's good. 0.3, okay. You know, we're within a count there. 0.110, 0.110. Okay, that's good. We're within a count there. We're assuming that this is reasonably accurate to 3 digits. I think it is. 0.01, 0.02, 0.03, 0.04, 5, 6, 7, 8, 0.08, I said. 0.09, 0.1, okay. It's within a count. I call that good enough. Let's go up. Let's see, 0.1. Yeah, same deal. 1.5. Good. Let's go back here. Let's go to 5 volts, which is a good power supply voltage. Okay. So if I'm measuring 5 volt power supply, which is what I'm going to do with this, I'm right on there. Okay. So I'm calling DC volts good. Let's try AC volts. Now I have a signal generator up here. It's putting out 1 volt RMS at 100 hertz. So we ought to measure 1. Well, yeah, like that. Okay, 1.001. That's actually pretty close to spot on. So, you know, I call that good enough. I'm not really going to use this for AC volts, but I call that good enough. I don't really have a current source handy. So what I could do is put it in series with my other meter. I could use this again as a current source, DC current again. Back to here, okay. There we go. All right, that's showing minus 14 because I've got it backwards. But that's okay. 14.8, 14.9 milliamps. Close enough. And I can turn the current limit up. 20.4, 20.4. Yeah. Yeah, so that's working. It obviously it doesn't range on this. It's strictly amps. So milliamps are down in the third digit. It's not very exciting. That's 13 milliamps. It doesn't work very well on low current. But again, I'm probably not going to use it for that anyway, so it's fine. Okay. Well, I'm calling it good. Okay, so I'm going to wrap this up by showing what I intend to use this thing for. I've got to say, this meter is not useful for much of anything except its novelty factor, if you ask me. The Fluke 8050 is, you know, if you're looking for a vintage meter that's actually useful, I would get a Fluke 8050A rather than a NHP 3476A. But it's kind of cute, and so what I'm going to use it for is monitoring my power supply. I have a HP 6281A power supply that's 0 to 7 volts and up to 5 amps, which I'm using to power the Nova 445 computer. What I've done is, this has, you know, adjustable voltage and current limiting. But what I've done is, because it brings these controls out to the back, I've put a fixed resistor in there. So this is set to 5 volts, and then I can adjust the current, or, you know, current limit, and I can view the current on the analog meter here. So I turn it on. There's my power supply voltage, and there's the current. It's drawing about 2 amps. And the current limiting is set. I don't know where that is. That's somewhere around 3 amps or so. Yeah, that's about, you know, that's about all it's good for. But you'll see it at VCF West. It will make the trip to VCF West, just in case you want to see it up close and cute, you know.